We've been talking about physical and chemical properties, and not all physical and chemical properties are equal. Some physical properties, for example, say color of an object. That's not very useful for in terms of identifying the substance, because lots of things can have the same color. However, there are some properties that are characteristic, and by this what I mean is they are unique to that substance. And if they're unique, we can use them in identification. So for example, melting point of water, 0 degrees Celsius. Boiling point, 100 degrees Celsius. These are unique features to water. Yes, there are other substances that might melt or boil at one of these temperatures, but not both. So if I had a chunk of solid liquid or solid and I melt it, and I see that it melts at 0, and then I keep heating it, and I see it boils at 100, those two factors would help me to determine that it's water. One characteristic physical property that we're going to talk about. Density is a physical property of particular interest because it brings us back to our definition of matter. When we talked about matter, we said it was anything that had both mass and volume. And what density does is it looks at the relationship between those two. So if I have a substance, what's my relationship between my mass and my volume? And we calculate density by dividing our mass by our volume. Okay? And so no matter how much of a substance I have, all of that substance has the same density. Now in science, we don't use the words, we use symbols to represent each of them. So we use the letter D for density, M for mass, small m for mass, and a capital V for volume. Now, density for solids and liquids is a fixed value, and they're pretty close to their actual volume. But the density of gases are dependent on the temperature and pressure, because the gases fill the volume of the container. So if I change the volume of the container, then I'll change the density of the gas. And temperature and pressure are related to the volume. Now, we have a number of substances here listed and their densities. What I want to point out is no matter how much of a substance I have, its density is always the same. So whether I have a kilogram of aluminum or a metric ton of aluminum, or I have 1 gram of aluminum, 1 roll of aluminum foil, a aluminum ball the size of a beach ball, they all would have the density of 2.70 grams per centimeter cubed. For liquids, we don't use centimeters cubed, we use milliliters as our measurement. Now, here's the thing. Because of the definition, 1 centimeter cubed is equal to 1 milliliter. Okay, so therefore, I can express the density of water as 1 gram per milliliter, but it's also equal to 1 gram per centimeter cubed. Okay, and we'll talk about that. Now, you will be required to calculate the density of things. And if we calculate the density, we can then be able to identify them. The density calculations, remember, we're going to use GRASP. Yes, I know it's an easy calculation. Yes, I know that some of you could just go, oh, it's 15 divided by 1.32. Oh, it's blah, blah, blah. We are training you to think how scientists would analyze a problem. So we use simple questions to learn a technique so that when we move on to harder questions, we have it down so that we can then apply it. And it gives us a basis to answer things that are challenging. So therefore, we're going to require you to use GRASP and to put down all the steps of GRASP. So the first thing is we have to identify our given. Okay, if you're having difficulty identifying your given, you circle your values and then look at the units on the values, because the units will tell you what it is. Okay, so for example, if we look at the unit here that's grams, grams is the unit associated with my mass. And then if we look at the units here, it's centimeters cubed, that tells me it's a volume. Okay, so now I can write down my givens. I'm going to use my symbols. My mass is equal to 15 grams. My volume is equal to 1.32 centimeters cubed. Then we're going to have to identify our required. Okay, we're asked to calculate the density. So my density is equal to. And I'm identifying the variable I'm looking for and its units, because this will help me to make sure I know what I'm doing and where I'm going. Then I'm going to identify how I'll solve for that. Okay, so in this case, we can use our density formula as written. Now I can substitute my values in and calculate. Okay, so now I have my density, and we're being asked to use it to identify. So it's 11.36. So I'm going to go to the table, and I'm going to look for something with a density of at or close to 11.36. In this case, it's lead. So I would say that my metal is lead. And the last part of GRASP is to paraphrase, to give a statement. So I'm identifying the density, which I was asked to calculate, and I'm also identifying what it is, which I was also asked. So this question was relatively straightforward. Let's try a bit. Okay, so let's take a look at a slightly harder question. So a pure sample of copper has a volume of 3.75 centimeters cubed with its mass. At first glance, it looks like we only have one given right here. We only have its volume. However, because we're told what our sample is, and we have our observation, we have a data table, we can also get its density. Okay, so when we identify our givens, we have our volume. Because we know it's copper, it allows us to get its density. So as a result, we have two givens, its volume and its density. Okay, then we want to identify its required, and again, I'm going to put the symbol, and I'm going to write its units so that it helps me to make sure at the end that I did it right. Okay, our analysis. Our density is equal to our mass over volume. This is a relationship. But now we have to do a bit of algebra. Because we want to know our mass, we have to isolate it and have only our mass on one side of our equation. So we're going to do a bit of algebra. We want to get mass by itself. So since we're dividing by volume, we'd multiply both sides by volume, and it'd remove volume from this side and place it to there. So my mass is equal to my density times my volume. Okay. Now that I know my equation that I need to solve for my required, I can now solve it, and I can take my values and substitute them in. And again, I'm using my units because centimeters cubed and centimeters cubed would cancel. So this helps to tell me that I've set it up right, and I have my mass. And now the final thing would be just to paraphrase and give my statement. Okay? The mass of the piece of copper is 33.6 grams. Let's take a look at one final example. In this case, we're told information about the size of it, but we're not told our volume. And we're told what the substance is. But we're told its length, width, and height, right? And so with these, we can get our volume because we know volume of a regular shape is length times width times height. And then we're told that it's a gold bar, so we can also get its density. So we have these as our givens. We know that that's our volume. Okay, we're required again for our mass. So we have our mass with our grams. Okay, and now we have our equations. Density is equal to mass over volume, and volume is equal to length times width times height. And again, we manipulate like we did before to identify, to isolate our mass. Now we can substitute in. Okay, and so I'm going to substitute my values for my length, width, and height, and I get my volume. Now that I know my volume, I can use it in my equation to solve for my mass. It's equal to my density times my volume, which I obtained here. And I get my mass. And I get my mass. Now, if you remember your metric conversions, we know that 1,000 grams is 1 kilogram, or we can, to go from grams to kilograms, we can move our decimal 3 places this way. So I have 14,252 grams, or I have 14.252 kilograms. Okay, and then our last step is our paraphrase.